The Baltimore, Ohio, and Western Maryland railroads had a dominant position in Cumberland, Maryland in 1953. Today, over a half century later, these railroads come alive again via the Cumberland West Model Railroad. The layout railroads operate in the same manner and environment as they did in their real-life setting. Only the dimensions and scenery have been compressed, and the tower lever controls have been replaced with CTC panels. The layout supports prototype operating sessions in this 1,200 square foot basement. The layout room was excavated under an existing residence in Los Altos, California. A companion video titled The B&O in Cumberland in 1953 describes the history, business, and operations of the B&O and Western Maryland Railroads in Cumberland. The video you are now watching deals with the Cumberland West layout infrastructure, electronics hardware, software, and operating paperwork. The topics to be covered include DCC Train Control, towers, signals, switches, uncouplers, telephones, auto train running, scheduling, and instruction booklets. These equipment, software, methods, and procedures are in use in 2015. They do not reflect the optimum, best of breed, or most appropriate given a fresh start and no legacy issues. DCC Train Control. The critical attributes required for train control are conformance with the NMRA DCC standards, reliable radio throttles, and support of multiple computers. The computers are necessary for towers with functional interlocking plants. Radio throttle options should include full function throttles with programming and consisting, and simple throttles or knobbies for most train driving. The computer connections support decoder programming, automatic running, and signal and switch controls with touch panel displays. We were not able to achieve the desired results with a single DCC manufacturer. In the Cumberland West complex environment, NCE furnishes the best radio throttle performance. Another, but less important NCE attribute is support of DCC advanced decoder-assisted consisting with directional aliasing. Only the Digitrax Loconet satisfactorily meets the requirements to support 11 computers and nearly 200 other electronic devices. In a network configuration this complex, changes are the only constant. The resulting design uses 3 hybrid Loconet cables. The center 4 wires of each cable are Loconet. The outer, pin 1 and 6, wires have 3 versions: NCE to support track boosters, Digitrax to support accessory boosters, and 12 volts DC to support devices that can draw power from the Loconet cable. The DCC signal and throttle control can be hot switched between NCE and Digitrax if necessary. The NCE throttles all have the Mark Schuster in-throttle battery recharging system. Throttles retain sufficient power through several operating sessions without recharge. The resulting battery life is approximately 5 times our experience with the Digitrax duplex throttles. Track boosters and track detectors require a DCC track strobe, for instance, for the Digitrax BDL 168, and use the NCE track control line instead of the Loconet rail sync lines. Accessory decoders requiring DCC power use a separate accessory booster. The computers which support throttle control have both NCE and Digitrax connectors. All 12 DCC boosters are Digitrax. Cooling fans are used to improve the average power output. The large number of boosters is primarily to distribute power and reduce electrical noise caused by long, high current supply runs. Tower control. The B&O Railroad in the area of Cumberland relies on towers with mechanical interlocking plants to control switches and signals. An interlocking plant is a section of track where the status of the switches and signals are interlocked as a safety appliance to prevent an unintentional route and signal conflict. An interlocking section may have several entrances and exits. Within the interlocking plant, the track may be single or bidirectional. In the Cumberland area, the B&O is double-tracked, but with a single direction of travel. Rule 251, or current of traffic regulations, predominate. The tower operator is the local agent of the dispatcher. Signals are B&O color position lights, CPLs, with 14 different signal aspects to regulate speed, but do not give any indication of routing direction. Between towers, control is essentially ballistic. The prototype towers have model board displays. The signals and switches are controlled with Armstrong hand levers. Cumberland West has 10 interlocking plants, some of which are relatively complicated, controlled by 5 tower operators. The panel CTC machine is fairly intuitive, assuming familiarization with CTC concepts. The B&O tended to favor general signal or custom-built CTC machines. However, the Cumberland West uses union switch and signal icons because of their GMRI availability and support, thanks to Dick Bronson of Railroad Circuits.
Evetts Tower, clear extra 961 West, Potomac 97 into Evetts Yard.
Clear extra 961 West Potomac 97 into Evetts Yard.
The operator analyzes the requested train routing and ascertains that all affected signals are showing a stop indication. The directional levers are placed in the center or block position and the code button is pressed. The code light blinks to indicate that coding is in process. When the code light is extinguished, coding is complete. The center direction light is lit to indicate a neutral or blocked direction. There may be an additional delay for reducing a permissive signal. The prototype signal reduction delay is 5 minutes and has been reduced to a modeler-tolerant 10 seconds. The required switch control levers may now be set and the code button again pressed. If the switch direction lamp is lit in the same way as the control lever, the switch movement code line has been successful. Finally, the signal direction lever is set and the code button is pushed once again. If the signal direction is not successful, the direction light remains in the neutral or block position or shows no light at all to indicate that an out-of-correspondence state exists. This demonstrates the essence of the CTC machine operation. The signal aspect will depend on track conditions and the information obtained from the adjacent towers via the code line. More advanced features include permissive signals, overriding track conditions, or call-on, auto-return to a clear signal or fleet mode, and switch locks for local trains. Additional design criteria includes optional automatic switch and signal control for the unmanned towers to support sparse crews and automatic running. The model board has various levels of operating assistance or training wheels. This is to allow trains to continue in an emergency situation caused by operator deficiencies, plant failures, or software bugs. The tower CTC displays are 9, 15, and 22 inches. The 9-inch is a pad computer used at the Western Maryland Railway's MY Tower. The tower displays have 4 main parts. The model board has a diagram of the control track. The switch levers control turnout positions. Track direction levers control the direction of traffic, and the code button instructs the interlocking plan to implement the desired routes and signals. Unlike the static prototype model board, the touch panel indicates actual switch position graphically. In addition, there are CPL signal repeaters and additional occupancy data for diagnostic purposes. The yellow border around the model board is an invisible shield, or programmable overlay mask that prevents the model board from being touched activated. The tower training supervisor or stage manager can enable the model board so that the switch and signal icons can be changed by touching. The original tower software was Digitoy's Winlock. This has now been replaced with JMRI Panel Pro. Pete Cressman took the event-driven logic invented by David Duchamp, added the control panel editor and other enhancements to support a full suite of layout functions. The new or improved features are a remarkable set of control and display graphics tailored for model railroading. Pete is also the developer of the Warrant automated train running system and the indicator track animated icon display graphics. The underlying tower software architecture is compatible with the implementation of a physical CTC machine. The panel events are separated from the dependent actions. In the future, it is planned that a physical CTC machine replace the touch panel display at Kaiser Tower. The new hardware CTC panel will use the existing touchscreen software. The software is configured so that any tower can control any function. Software development is done on a computer with all software for both railroads functioning simultaneously. The computers communicate via Ethernet for administrative tasks and Loconet for operational functions. Signal control. JMRI has built-in signal control functions that meet the majority of model railroad signal requirements. The virtual signals on the hidden portion of the layout use the built-in functions that now support many of the B&O CPL mast aspects. The Cumberland West on-layout tower control and signal logic is more complex and requires customized logics-based code. B&O CPL signals have a central head and many separate marker lights. The signal logic specifies a mast aspect. The signal definition translates the mast aspect into signal head appearances, which are in turn translated into switch settings to be transmitted over Loconet. Some distributed signal driver boards, such as railroad circuits, Ingenious LNCP, can decode masked aspects directly into the illumination of signal lights. The Cumberland West B&O signals support up to 9 of the possible 14 aspects on any one mast. The schema was designed to work within the limitations of the Digitrax SCHC, which at design time was the only Loconet device available for this purpose. The 3 main aspects of clear, approach, and stop were defined as one head. The restrict aspect and a pair of upper and lower marker lights were defined as the second head. Today, more versatile signal driving appliances from railroad circuits, model railroad control systems, and others simplify even the most complex signal network. Signal aspects generated in the towers are transmitted on Loconet. The dispatcher, stage manager, and other supervisory positions can monitor layout status. A signal repeater system developed by Kevin Dickerson automatically generates the newer mast messages to support remote monitoring and display. The calculation of the signal aspects begins with the local track conditions and the tower panel logic. JMRI Logic's conditionals are defined for clear track conditions. A clear condition requires that track switches and occupancy states are permissive. A clear conditional must be defined for each possible route through the interlocking plant. A second approach conditional is defined for the state of the next interlocking plant. The information for the approach computation may have to be transmitted over Loconet from an adjacent tower. Loconet only transmits switch, sensor, and signal aspect messages. Expansion plans for Loconet, CMRI, or the proposed NMRA Open LCB may simplify future network design. The tower operator's panel actions are analyzed. Additional JMRI conditionals record the status of the lever switches and code button. The event triggers define when the panel request should be interrogated and the resulting signal aspect computed. 2 additional panel features are the call-on and fleet mode functions. A call-on allows a permissive signal to be given under track conditions that would normally cause a stop signal. Call-on may be used to allow a local train to approach its own cars previously parked on the controlled track, or a light engine movement for hostling or helper moves. On a prototype CTC machine, the call-on is usually activated by simultaneously pressing a call-on button and the code button. The computer touchscreens do not support multiple icon selections, so the call-on button remains active for 20 seconds. If the code button is pressed before the call-on times out, a stop and proceed permissive aspect can be generated. The B&O's call-on aspect is stop and proceed at restricted speed and prepared to stop again. The restrict aspect can also be used for call-on. On the Cumberland West layout, restrict is reserved for entering yards or other dark territory. When a train passes through an interlocking plant, the permissive signal is replaced with a stop because the train is now occupying the protected track. The CTC panel direction light goes out. This signifies that the direction lever and the signal are now out of correspondence, and a new route must be established for the next train. The fleet mode switch allows the signal aspect to automatically return to a permissive indication after the train passes. It is not necessary to repeat the route establishment procedure for the following train. Although handy for fast-paced repetitive model railroading operations and essential for automatic train running, fleet mode is seldom used on the prototype. A bell alert indicates an approaching train from a non-viewable location. Non-prototypical audible verbal alerts help point out particularly puzzling route conflicts. Verbal alerts are used sparingly and usually only as a training device. Conflicting route. Switch 251 and 252. Unlike the B&O, the Western Maryland had few signals in the Cumberland area, and where they existed, they were simpler than the B&O signals. The Western Maryland layout signals are mostly hazard warnings to prevent collisions in tunnels and control movements to and from staging. Train orders were used for dispatching control, with a single passenger train with timetable authority. Lever-operated train order boards were prolific and used throughout the system. On the layout, the train order boards are controlled by the dispatcher, stage manager, or tower operator using computer lever icons. On the Cumberland West, the train order board can be used by the dispatcher to effect an OS by the train crew at an otherwise unmanned station. Automatic OSing by train crews at all locations would saturate the phone system and generate little useful information. The train order boards alert the train crew that new train orders are to be picked up at that location. A Form 19 partially raised train order board indicates that the order must be picked up, usually clipped to the fascia. A Form 31 with the train order board in a fully horizontal position indicates that the train must stop, sign for the order, or call the dispatcher if no order or operator is present. The Western Maryland train order boards are a three-position lower quadrant driven by the Digitrax SC8C. This was convenient since the SC8Cs were already being used as drivers for the B&O CPL signals. Although economically efficient, the SC8C is awkward and unforgiving to program. The Railroad Circuit's Tower 64 will perform the same driver functions with greater flexibility. Almost all the Cumberland West signals and train order boards are from Tomar Industries. The three-position train order boards are controlled by Tortoise switch machines using the Tomar remote cable actuator. Chuck Catania, our signal maintainer, plans to replace the Tortoise with a servo-based control with exact positioning. Switch control. All track turnouts are actuated by Tortoise stall motors and cause minimum wear and tear on the 350 hand-laid turnouts. The Tortoise motors themselves are bulletproof. However, the contact wipers and edge connectors often fail. For diagnostics or special operations, the towers and Loconet can be bypassed and all turnouts on the visible layout controlled by fascia toggle switches. The facial toggles are momentary so that they cannot give a false indication of switch position. Digitrax DS54 and DS64 stationary decoders support this local switch control feature. These switch control devices also furnish a feedback message so that other devices and computer displays are aware of the status of switches thrown locally. Yard throat switches sometimes use track selection buttons. The required turnouts are thrown using a combination of local routing, if the turnouts use the same control card, and Loconet messages if different cards are involved. All turnouts are driven by DCC accessory decoders and can be thrown by throttles or computers. Unlocking switch and tower locks are used to activate track switches otherwise off limits. On the B&O, all mainline switches are under the exclusive control of the responsible tower. The movement of the switches is governed by the CTC panel logic. The operations supervisor using the stage management panel may temporarily grant permission for a tower operator to directly manipulate track switches and signals by activating the model board touch panel. The tower operator and layout supervisor can also grant permission to activate all the fascia switch controls. This allows the rapid movement of trains without bothering to accommodate the tower logic. This is the normal mode of switch control outside of formal operating sessions. The hardware is designed so that in the event of a tower shutdown, all local switch toggles are activated. In the prototype, the boundaries of the interlocking plant were limited to a few hundred yards, which is the practical limit of a manually thrown turnout control rod. Switch key locks are used to grant control of mainline switches to local switch crews. These remote switches were not directly protected by signals and cannot be used by mainline trains without special permission, such as train orders. The tower operator gives a local train permission to unlock the required switch using a switch key. On the layout, several switches may be controlled by a single lock. The unlocking process connects an occupancy circuit across the affected main line or main lines, preventing a tower from granting access to another train. At the conclusion of the local switching move, the turnouts are returned to normal, the switch lock relocked, the key removed, and the tower notified. If the turnouts have not been properly normalized before relocking, a blinking red hazard light next to the lock is activated. A permissive signal is prevented while the switch lock hazard light is illuminated. All the layout towers control two or more interlocking plants. At Cumberland's Virginia Avenue interlocking, the William Street switcher supports switching for passenger trains stopped at the Cumberland station. These movements are complex and remote from the controlling tower at Viaduct. Speed is essential to meet the passenger train schedule, and the switch crew can unlock the entire Virginia Avenue interlocking for local control. Layout status and power control. The circuit breakers are almost all DCC solutions, PSX and PSX-AR. These devices accommodate the high inrush currents of some sound decoders and have a variety of connections and programming features to allow special control and status reporting. Circuit breaker status is transmitted over Loconet to the supervisory displays. A display panel shows all circuit breakers and a layout map with affected areas highlighted. Color coding is used to distinguish between B&O and Western Maryland track and between the visible and hidden under layout track. Train tech's aux boxes control staging track power. This device accepts DCC commands and switches high-power circuits with exceptional reliability. The staging control panels have several power options that allow DCC power to be turned off on tracks that are not being utilized. Power can be manually cut, tied to the position of the in or out track switches, or activated by the termination of a train run as an emergency stopping device. Unfortunately, the use of keep-alive circuits with DCC decoders defeats cutting track power for emergency stops. Uncoupling control. There are a few places that cannot be easily reached where power uncoupling is necessary. KD electromagnets are actuated by fascia buttons. A railroad circuit's Tower 64 maintains the current for 10 seconds. The uncoupler can also be activated remotely by tower panels or automated train running warrants. Telephones. The Cumberland West telephone system uses an historic Western electric key system that was in vogue in 1953. The complicated system has 7 independent lines with 16 stations. This allows for the separation of communication function for most activities, with both railroads operating at the same time. The telephone system was designed and constructed by Seth Newman. The The push-to-talk and noise cancellation headsets have been added to improve reliability. Each station has a unique ring using a buzzer with the station's railroad Morse code signature. Fortunately, most operators quickly recognize their call without overtly learning the code. The ring signals are captured by Loconet and available for on-layout or tower ring repeaters. B&O towers and the Western Maryland train order boards obviate the need for most on-layout ring indicators. The phones are connected by historic 25 and 75 pair cables using 66-block punch-down connectors. Automated running. There are several scenarios for automated train running. The most important reason for automated running is train and engine hostling. Automated hostling improves the efficiency of the operating crew. Cumberland West's very long runs to staging and massive staging yard contain a half-mile of track and over 100 switches. Prior to automated running, staging would require as large as a 5-person crew. The second reason for auto train running is moving scenery. This allows an operating session featuring one railroad to have operating elements of the other railroad in the background. The third use of automated trains is pageant running, which tells a transportation story mimicking a simplified operating session without the crew in the aisles. Cumberland West automatic running uses the JMRI Panel Pro warrant system. The warrant is a script that governs train movement. In order to use warrants, the layout track must be defined in terms of indicator blocks, portals, and paths. Indicator track changes color based on track and warrant status. Occupied unselected track appears orange. Track selected for an automatic run appears green, and train location now appears blue. Any out-of-service track is gray, and error or shorted track is red. The train identifier marker can be made to move manually or automatically as each new block is occupied. Automated running may be performed with the NX warrant that builds a running script based on the beginning and ending blocks. The warrant system displays all possible routes between the 2 points, and the preferred route is selected. The warrant begins its run with gradual starts and stops, and in conformance with all speed restrictions and signal indications. If desired, this temporary script can be saved and run again without repeating the setup dialog. Recorded warrants are stored scripts that can be generated from NX automated warrants or recording the movements of a train running on the layout. Recorded warrants can be edited to alter the speed profile, actuate DCC train functions, and have two-way communication with the event-driven features. These interactive script events could be crossing gates or hazard alerts that are dependent on train progress. Script progress is controlled by occupancy sensors and time. If the script was generated from the actual run, the warrant will seek to maintain the spatial relationship between the train's actions and intended train location. While the train is running, the script progress can be paused until an external sensor message is received. Likewise, the script can issue a sensor message when a specified point in the script is reached. Warrants can set routes and check for block occupancy or track allocation involving other trains. Signals, indications, or an unintended track occupancy can control the actions of trains requiring the same track. The train will respond by slowing down or coming to a complete halt. When the intrusion is removed or a permissive signal is restored, the train will resume normal progress. Automated running using warrants requires the specification of track in terms of the blocks, portals, and paths. If there is an existing JMRI Panel Pro track diagram, the indicator track can be created with the aid of the Circuit Builder tool. Occupancy and error sensors are added to the block table. Each path will require a list of turnout routes if the warrant is to throw switches in advance of the train. Operating schedule and forms. Operating schedules, train lineups, train sheets, and stage positioning forms are interconnected Excel spreadsheets. All data and times are keyed to the start time and fast clock multiplier and entered only once per op session. A string line diagram to aid in traffic plan is an optional report. The coal management system produces coal and car orders using the current mine and yard inventory. Waybills are destination color-coded for quick reference routing. Instructional booklets. The instructional booklets are produced using MS Word and Publisher. Sam Romerstein, Dick Zarin, and Jim Betts have been instrumental in producing these documents. The B&O booklets include B&O train operations, tower operations, Kaiser Yard operations, employee timetable and rules, summary operating procedures, and a B&O layout map and traffic schematic. Western Maryland booklets include MY Tower, Elkins Yard Operations, Western Maryland Dispatching, Employee Timetable and Rules, Summary Operating Procedures, and a Western Maryland map and traffic schematic. Conclusion. The Cumberland West Model Railroad has a complex infrastructure. The future of Cumberland West is planned to include automated engine hostling, pageant running with auto scheduling, auto train tracking with video, simulation workstations for stage runs, RFID train ID, on-scene lighting, mood, weather, and time of day lighting. The intellectual backbone of the illustrated features are JMRI Panel Pro and the Digitrax Loconet. In addition to the developers mentioned in the presentation, at least 45 others, including Bob Jacobson, the JMRI spiritual leader, have contributed to features used on the layout. Cumberland West infrastructure was only made possible by the support of the hardware manufacturers and the CW mentors who assisted in the implementation. This video is directed and edited by Leo Pesci of LPR Productions.